Okay, this is section 2.6, our last section. Would you consider taking some solid notes right here? So 2.6 is what we're talking about. All right, so you're setting up your notes just like this. We're going to talk about a kite, and we're going to talk about a trapezoid. And I have a kite attached to today's Google Classroom assignment. So when I get back over here, you can see this one right here is going to be the kite, and then this one right down here I think is the trapezoid. So I've already opened up the kite, and what I want to do is I've kind of rotated it around so it's more in a normal orientation. What I mean by that is, like, I've got this point at the top that I can drag up and down. I mean, it kind of looks like one of those old-fashioned kites. I don't know if you've ever seen one of those or not. But quite often these kind of kites, they have a stick that goes between each one of the vertices like this. There's a stick going there and a stick going here. These are called the diagonals, right, of our kite. And I just want you to look at what you notice with these diagonals, okay? Would you do that for me? What do you notice when I move this around about the diagonals? Like, I could stand it up like this, or go like this. What do you notice when your eyes are looking right in here at the diagonal? What do you see, right? That's what I'm asking you to look at. So I hope you're saying, well, it looks like they're right angles in here, right? Where the diagonals hit each other, they're right angles. And I hope you're also looking at this piece here of the diagonal and this piece over here, and they look equal to each other. So let's do that on our diagram over here. Let's add a diagonal. So, man, this is I'm gonna switch to my segment tool. I'm gonna cheat here. So I'm gonna add a diagonal from here. Whoa, that's weird. Let me try that again. I'm gonna go from here to here. There's one of my diagonals, and then here's another one of my diagonals going this way. Oh shoot, it just switched back. So come on, man. So like this. All right, now I'm gonna mark up my diagonals. What did we just say? Well, they're perpendicular to each other, so put a little right angle symbol in there, okay? And then they're equal to each other right there. So let's zoom in. Why am I so zoomed out on this thing? So we got a right angle. That's what symbol I'm trying to put right there. Let me try again. Okay, so there's a right angle right here, meaning 90 degrees. That would mean all these angles are 90 degrees, right? So right out here, why don't we put down diagonals are perpendicular to each other. Diagonals perpendicular. Now, does it look to you like this shorter diagonal is getting bisected by the longer diagonal? Yeah, I hope it does. So one diagonal is bisected by the other. Okay, put that down in your notes. But it's not both diagonals getting bisected, it's only one. Now, how do we tell which one it is? Well, in a kite, there's two sides that are equal. They're consecutive sides that are equal. And then there's two other sides that are equal to each other. And it's the diagonal that's going between the two different length sides that's getting bisected. And the diagonal that goes between the equal lengths is bisecting the angles. So let's put angle down here equal to each other, and then put two tick marks up here, because these angles up at the top of my kite are different than the angles that are down here on the bottom of my kite. But these two are equal to each other, and these two are equal to each other. So there's an angle bisector going on. Angle bisector with one diagonal, and then the other diagonal is not doing anything to the angles that we can conclude. Like this shorter one right here is not bisecting the angles over here. See, we're going to use these properties to make some of those deductive reasoning conclusions. Do you see how we have a right triangle in here? Right? So this angle being a right angle right here, I want you to emphasize that. They're going to make us use the Pythagorean theorem again, right? That's what we quite often do with right angles, with right triangles. They're also going to say probably like, hey, this angle up here is 30 degrees. How big is this angle right down here? And I hope you're going to go, oh, it's 60, because 30 and 60 make 90, and 90 more makes 180, right? You'll do something like that. Okay, so that is the basics of a kite. And you can mess around some more on GeoGebra if you want with this kite and just see if some of that makes sense, you know, to you. Like, you could measure the angle in here. Let's do that real quick. Can I measure this angle right here? So if I go 1, now there isn't a point there, so I'm a little worried. So is it going to let me click on that? It won't let me click on it. So let me undo that, and let's go up here. Let's put a point where they intersect. Now it's going to let me measure the angle. So I'm going to go 1, 2, oh shoot. Remember, I have to go clockwise. Right now I'm going counterclockwise. So let me try that again. Let's go measure angle. I go 1, 2, 3. Oh, it's just putting a right angle there for me. Beautiful. So that's what I was hoping it would do, you know, and show me that, look, no matter what I do with whatever I do with these diagonals, this right in here always stays as a right angle. Okay? Like I said, you can mess around with this some more, but that's probably enough for now. The next shape that we're going to look at is a trapezoid. So let's jump over to Google Classroom, and this guy's in my way. Let's open up the trapezoid. Come on, GeoGebra. You can do it. There we go. Okay, so let's try this out, see what we notice about a trapezoid. Okay, what are you seeing when you move these around? Are you seeing something happen? That's not letting me move that side. Uh-oh. Why is it not letting me move that side? Oh man, it's not letting me move that. Oh, here we go. I just grabbed that point over there. So what are you seeing happening with the trapezoid? Like, let's leave it right there for a second. Hey, these two sides are parallel to each other, right? So we've got two sides that are parallel, and let's mark them like this with little arrows. That means they're parallel. And then these two are not necessarily parallel, okay? They could be. If these two are parallel, then we have something special, a special type of trapezoid called a parallelogram. But usually when we think of trapezoids, there's two sides that are not parallel, and then there are two sides that are parallel. These are called the bases. So this one up here, I'm going to call it base 1, and then this one down here, base 2. The reason why I'm giving one a 1 and another one a 2 is because they're different lengths quite often. The bases are different lengths. These angles here are called base angles, and so are these angles up here. Now, I just marked them equal. Soon as I mark them equal, I know this is a special type of trapezoid called an isosceles trapezoid. So if two of the sides are equal, it's called isosceles. And let's look over at some of my notes here. So a trapezoid has two sides that are parallel. If the legs are equal, then it's called isosceles. Okay. Now, I haven't said anything about this mid-segment right here. So let's draw a mid-segment in. It looks like this. Okay. You find the midpoint of this side, and you find the midpoint of this side, and then you connect them. This thing right in here is called the mid-segment. Add that to your notes. That kind of came out weird. Add that to your notes. All right, so what is the mid-segment equal to? It's equal to the average of the bases. So let's put that right over here. Our little formula for the mid-segment is 1/2 base 1 plus base 2. So here we go. 1/2 base 1 plus base 2. Okay? So let's do it. Base 1 plus base 2. Okay, what else do you see in this trapezoid that would be true? Well, right now, if it's isosceles, you know, like I said, these base angles would be equal to each other. We also know that because the top and the bottom are parallel, these two bases are parallel, this angle plus this angle equals 180 degrees. They're supplementary. So consecutive angles between the two bases, those two add up to be 180. So add them. Let's see, where am I going to put this? Equals 180. Okay, 180. That means they're supplementary. Okay. How am I doing with that? Is that clear? So, man, this thing acts so funny. Let's see, supplementary. There we go. So I think that's all I need to say about trapezoids. I want you to open up the assignment. I want you to do the best you can. And when you look back here at our assignment, it says we're going into section 6, trapezoids and kites, and that's in McGraw-Hill. So thanks for taking some notes and follow along with me. As you come across a problem in the homework that you might not be able to do and you have to add some information to it, well, add that piece of information to your notes. Okay? Thanks, everybody.